Hello everyone. Today we are going to see a few more questions on the topic of triangles. I hope the previous video where we discussed two questions were helpful to you and I hope that this video too you find them helpful. The questions are little different, simple versions but little different. So I hope they help you. Let's look at the first question. The first question says DB is perpendicular to BC. DE is perpendicular to AB and AC is perpendicular to BC. And we are supposed to prove that, we have to prove that BE upon DE is equals to AC upon BC. Now, if you look at the question, whenever we do questions from the chapter of triangles, we know whenever we have to prove proportion of sides, the sides in the numerator belong to one triangle and the sides in the denominator belong to the other triangle. If I look at this, I have BE and AC which belong to two different triangles, right? And we have DE, let me use another color for you. DE and BC, they too belong to different triangles. But we can see that BE and DE are belonging to the same triangle. So what we can do, we can just modify the question and we can write this as BE, we interchange the positions of AC and DE. So we are going to get BE upon AC is equals to DE upon BC. And with that, we know we've got our triangles, the two triangles that we want to prove similar. Once we prove that these two triangles are similar, rest is by taking corresponding sides of similar triangles, we'll get the ratio. I hope you have understood what is to be done. Now, if we look at the questions, let's look at the question. We are going to look at triangle. We are looking at triangle BED and triangle ABC. Okay, we are looking at which two triangles? BED and ABC. Let's mark what we know. We know angle E, that is DE is perpendicular to AB, so angle E is going to be 90. Likewise, AC is perpendicular to BC, so angle C is 90. So we get that. But we do not have any other part similar, right? In that case, we'll look at what is common to the two triangles. We have a 90-degree common and we have this angle which could be relating to the other two. So we'll write here, we'll say in the proof part, we'll say in triangle ABC, we know angle C is 90 and we'll say let angle B be X. That means we are calling this angle as X. Correct? Second that we know is DB is perpendicular to BC. That means angle DBC is 90. Right? DBC is nothing but angle DBE plus angle ABC. DBE we don't know. We don't know DBE. So we'll write this as DBE. But ABC is this angle. And we have already written that this angle is X. We have assumed this angle to be X. So we'll write here, in place of ABC, we shall write X is 90. And therefore we get angle DBE is 90 minus X. Right? Similarly, if we look at triangle ABC, we know angle C is 90 and we have assumed angle ABC to be X. We know that angle A plus angle B plus angle C is equal to what, children? Yes, using angle sum property, it's going to be 180. We'll write here angle sum property of a triangle. A is unknown. B, we just now wrote that B is X. We've assumed B to be X. And C we know is 90, is 180. So we'll write here angle A is 180 minus 90 minus X. Angle A is 90 minus X. So what did we get? We've got angle A as 90 minus X and also we got angle DBE from here. Angle DBE, this angle is also 90 minus x, correct? So that means we've got the second triangle, a second angle of the triangle to be equal. Now we can compare. So we write now, which two triangles are we comparing? We are comparing triangle DBE and triangle ABC. So first part is the 90-degree angle, right? Which is 90? Angle E is equals to angle C because each is 90. So we write angle not B, angle E. Angle E is equal to angle C. Why? Each is 90 as they are perpendiculars. And we just now proved that DBE is equals to angle BAC. We proved above that A is 90 minus X, DBE is 90 minus X, so they are equal. And so we get triangle DBE is similar to triangle. D is the unmarked angle, and over here B will go with D. With B over here, which is 90 minus X, we have A, which is 90 minus X. And with E, which is 90, we have a C, which is 90. So the two triangles are similar by AA test. Now, what would be the next part? Since the two triangles are similar, can we take their sides in proportion? So we are going to get BD we are going to get BD upon BA or AB is equals to BE upon AC, and that in turn is equal to DE upon BC. Look at your question. Do we need AB anywhere? No. So that means we can, for now, we leave this bracket aside. We don't need it. So what do we write? We write BE upon AC is DE upon BC. Very similar to what we modified. And now let's write it in the form that is expected. Interchange the places of DE and AC. We are going to get BE upon DE is equals to AC upon BC. And that is how you're going to get this question. I hope everyone has understood this one. Let's look at the next question, children. Here we are given triangle ABC is a right angle triangle. What is given to us? ABC is right angle triangle. That means we are given ABC right angle triangle, right angled at C. That means angle C is 90. We are told BC is A, AB is C, CA is B, and P is the length of the perpendicular from C to AB. That means it is a perpendicular over here. We need to mark this as 90 degree. Right? We mark it as 90 degree. This is the information given to us. And we are asked to prove that CP is equal to AB. Excuse me. We are supposed to prove CP equals to AB. Now, children, this is a question from the chapter of triangles, and we are using similarity for of this. We know whenever we prove any two triangles to be similar, we'll always get the sides in proportion. But here we are given as products. If I have something of the form, let's not use A, something of the form, say x upon y is equal to u upon w, then at any stage I can cross multiply and write them as xw is equal to uy. This is what the question form is. So we can write this as the form in the form by separating one of the sides or by transposing one of the sides. So if you want, you can fix C over here and a B over here. I'm transposing A. If you want, you can bring down B over here. And P definitely will go to the other side. Same way, you could have kept P over here and you could have transposed C. That means if we manage to prove this, we'll get the question. Now, why have we written the question in this form? Why have we expressed the question in this form? So that we can figure out which two triangles do we need to prove similar. As discussed earlier in the earlier previous videos, we have told that both the numerators are going to be sides of the same triangle and the denominators are going to be sides of the other triangle. So with this, we will be able to identify which two triangles are we going to prove similar. So if we look at it, we have C. C is here. C is AB. So we have first side as AB and the second side is B. Where is B? B is here, AC. That means if I complete the triangle, numerator is talking about triangle ABC. And the denominator. Now, if we look at the denominator is A. Where is A? A is here. And we have P. P is here. If I complete this, I'm going to get triangle BCD, right? So that means we have to prove that triangle ABC is similar to triangle BCD. We are just talking about triangles. We haven't taken their sides in proportion. I hope this is understood how we managed to understand which two triangles are to be taken to prove that they are similar, right? This is our understanding of the question, and then we start with the proof. Definitely, what do we know? Angle C is 90 and angle D is also 90 because it's given that angle C is 90 and it is given that CD is perpendicular to AB. Hence, we say that angle D is 90. Now, look at the two triangles. Which are the two triangles? In triangle ABC and triangle BCD. Where is BCD? ABC is the entire thing. BCD is this part. BCD is this part, isn't it? That means we are talking about these two triangles, triangle ABC, and we are talking about triangle ABC. ABC is here. We are talking about the pink triangle and we are talking about the green triangle, right? Triangle ABC and the triangle PQR. Sorry, ABC and BCD. So definitely we have first angle C is equals to angle D. Why? Because each is 90. Each of them is 90. And if you carefully look, this is an angle which is common to both the triangles ABC as well as DBC. So we can say that angle B is equal to angle B because it is a common angle to both the triangles. Common angle. So triangle ABC is definitely similar to triangle DBC. But what is important when I'm writing, I'm just mentioning the triangles, the order can be anything. But when we are writing the triangles as similar, we need to write the vertices in correspondence. So how do we check that? See, angle B is the middle vertex and we know angle B is equal to angle B. We know that angle C is equal to angle D. So which is the vertex left in the pink triangle or triangle DBC? Angle C. So we get angle ABC is similar to triangle CBD by AA test. Now because the two triangles are similar, can we take the sides in proportion? We'll get AB upon BC is equals to BC upon BD, which is equals to AC upon DC. Reason, we'll write a corresponding parts of similar triangles. Do we know AB? Yes, we know AB. AB is C. AB is C. What about BC? BC is A. Again, we have BC, A, and we have BD. Do we know BD? No, we don't know BD. That means we will not be using this proportion. We don't need this part. Which one? We don't need it for now. Moving on to AC. What is AC? B. And what about DC? DC is P. If I cross multiply, what are we going to get? We'll get the same question. C into P is A into B. And this is what the question was. I hope you all have understood. Again, I'll repeat, children, please write and practice. That is going to help you. Thank you.